asking.
We're live. Okay, cool. So this is a joint meeting of the Voltage team and the Bitcoin Core App team. We're going to look today at an open source block clock component that we built at Voltage, which is based off the design work of the Core App team. So the point of this meeting is to just kind of, now that we're open sourcing this UI component, just kind of share it with the world here, show off how it works, talk about some of the challenges we encountered while building it, and yeah, just open the doors here to potential collaborations on this. So yeah, I'm Steven, a product designer, work at Voltage. And then I got here on the Voltage side, Brandon and Lightning Koala, who actually did all the front end work and all the coding for that. And then everyone else here has, throughout the years contributed to the Bitcoin Core app project from a design and UX perspective. So that being said, I'll stop rambling and just open it up to where we should go next with this.
Yeah, okay. Hey everybody. I'll take us through the initial demo. Koala, feel free to chime in wherever I missed something. But yeah, it's great to be meeting with you guys, and it was a really fun project to work on. So I'll go ahead and go through what we did. So let me share my screen here. Share the entire screen. Yes.
This is really exciting. This is the first implementation. Like, this is really exciting.
Yeah, it was exciting for us too.
Yeah.
It was tough,
Okay.
especially some of the math. It's very mathy project, right? Getting the clock to work correctly. But yeah, so I guess the first thing I can show is I'll drop a link to, this is the GitHub repo. It's open source. Anyone can go to it. I can go ahead and drop this in the chat here. But yeah, so this is the block clock. This is like our GIF of it loading. At a high level, the way this works is you pass. It's a web component, right? So we built it this way because we wanted uh, anyone essentially to be able to run this in whatever framework they're using, right? Whether they're using Svelte or React, Next.js, or if they're just using plain old HTML. So we thought that would be kind of most in line with what you guys are trying to do, which is just make this like, more universally accessible to people. And then, the fact that this is kind of a standalone component allows people to, obviously you can use it in Bitcoin Core app, but it kind of allows for a bit more broad usage for whatever people might want to use this for. So this is a direct connection to a Bitcoin Core node via RPC. What you see it doing here in this GIF is it's actually like making RPC calls as we go. We looked into this. There wasn't actually a way to get all the blocks at once, right? Because what we basically needed was a way to calculate the distance between the timestamps of each block, so that we could do this chopping, um, and so yeah, so that's kind of how that is working. Is it's using a combination of the get blockchain info RPC call to see where the tip is at, and in addition, I think it's get blocks, or, well, we can actually look at the RPC calls in here, but it's basically like taking timestamps from the head and going backwards, making RPC calls to get the distances between the blocks. So yeah, so that's kind of high level how it works. You can use this as both an npm module, or you can add it as just a script tag drop in to your JavaScript project. Let's see. There's a lot of little notes here about how it works. a lot of little nuances and a few ways that we deviated from the design that you guys implemented. Just for some of it, because the implementation details, it was like hard to think about. Does the design actually kind of line up with what we had to do for our use case in Voltage? But we'll get to some of that. One of the things we added was actually the ability to connect MutinyNet nodes or to display MutinyNet nodes. So are you guys familiar with MutinyNet or that project?
Might need a little explanation there.
Yes.
Okay, so I'll just briefly, it's basically a custom signet that the Mutiny wallet team built, or they implemented for their own internal testing. Block times are 30 seconds as opposed to 10 minutes. And that's really the big difference, right? Because they wanted to be able to iterate faster. They found themselves like waiting a long time just to be able to test their own tooling. So for the Mutiny team, this was much simpler to just build this and use it. And we actually allow people to run MutinyNet nodes on Voltage. So just for development purposes, essentially, just Voltage. That's kind of one of the things we're trying to do, is make it easy for people to develop on Bitcoin, right? So that's kind of a brief overview of what MutinyNet is. And since we do that at Voltage, we allowed kind of two modes for the block clock, right? So in Bitcoin Core, in the Bitcoin Core.app block clock design that you guys had, you had the you had it basically resetting the interval every 12 hours, right? Which is what we implemented that for mainnet. And then for MutinyNet, because the block times are so short, we basically just did 1 hour intervals. So this is like a prop that you can set, or an attribute that you can set on the web component element. So yeah, I'll just show a little bit of what it looks like in our UI. I mean, this is it. This is a live version of the real thing. And yeah, this is kind of how it works. It implements a lot of nice things like caching and things, so that you don't have to basically, like, if I refresh the page here, I will get logged out. Actually, I wasn't forgot about that.
So caching's broken right now as well. we thought we fixed it
Okay.
on Friday, but just probably like this tiny thing that needs to be looked at.
It just worked for me, it looks like, actually. So maybe there's like some edge case bug. But in this case it worked. So yeah, so you don't have to like see that reloading thing every time. But yeah, so this is kind of what it looks like in a production app. So this is mainnet. We also have MutinyNet versions as well. And you can see this is kind of what it looks like loading in there, the MutinyNet blocks.
Show the dark modes.
You can look. Oh yeah, of course. How could I forget dark mode? Yeah. So there's dark mode. These colors, by the way, are customizable. So this is the default. Like, if you don't do anything, this is what it'll look like. But if you for some reason have a desire to put other colors in there, you can do that, and you can specify like how many blocks deep you want each color to be. So we defaulted to 6 blocks, and then everything looks the same. So it's like this earliest block here. We can see you just got a new block. That's the cool thing about MutinyNet, by the way, is that because the block times are so short, you can actually see this is like the pending block, and this is the time stretching out as we go. So it's literally updating that SVG, and once it hits the new block, once it detects the new block, that first block will become red, and the gray block will basically become a red block because it's been confirmed, and then the next gray, I guess, mempool block will start growing in size. See, there you go. It just did it again.
Can I jump in real quick, Brandon?
Yes, please. Yeah.
I just wanted to like maybe say the MutinyNet stuff again in different words. So like like we were talking about, like what Brandon was just talking about, like MutinyNet has these 30-second blocks. They're quicker. If it wasn't apparent before, like the issue he was talking about with like, okay, 12 hours versus 1 hour, it's because you see how many blocks are being coming out on MutinyNet. Like there's like 2 every single minute. So they're super tiny. So if we had this thing on like a 12-hour interval, then like you wouldn't even see any of the MutinyNet blocks. Like they'd be so like razor hair thin. I mean, it would look like garbage. That's why but we didn't want to just like leave the block clock out of the MutinyNet node. So that's where this idea of, okay, for MutinyNet, it's going to be 1 hour clock instead of a 12-hour clock. Then we can still show it in MutinyNet.
Yeah, and we found 1 hour to be a really good compromise because it's basically 60 minutes, right? So as you go around the clock, it's still quite easy to reason about it. Like a quarter of the pi is 15 minutes, then it's like half an hour, and then it would still render kind of a nice sort of set of blocks, sort of like segments. We call these like the ring segments around it, so you can still see it. So that was the compromise. Was like, oh, 1 hour fits pretty well.
Yeah, that's a great point. We actually before we had implemented this, we had just tried a MutinyNet node on this to see what it would look like with our 12-hour implementation, and it was just like drawing SVGs all over the screen. It was completely nonsensical. I think because the segments are so short that it couldn't actually render the logic properly. So yeah, great. Thanks for adding that clarification.
Yeah, one thing about that is that if you notice, there's a gap between each segment. So to what's the word, to keep those gaps in, you can't have too much, because otherwise there's no space for gaps, and then you just end up with a solid line. And the gaps are always consistent. Like when you look at the mainnet block clock, you'll see that the segments might change size. Like here, they're all the same size, but in the other one, they might change size, but you'll notice the gap is always consistently the same gap. And they also account for the kind of offset that creates, because it takes up space around the circle, right? So you see the gaps there are all consistently the same size. Yeah, there was a lot when Brandon mentioned there's a lot of math around it. Like this part was one of the hardest parts, was like figuring out the math around having the gaps, but also and then you see it's rounded as well, but sometimes it's not because it's too small. So all those things were like really heavy to kind of figure out the details, but eventually we did. Obviously, if there's like a block with like 0, as in like sometimes there's 2 blocks coming at the same time, I think they would be not visible. I can't remember now, but or there might be a tiny gap.
And just to, everyone may have seen, like, as he brought that screen up, it was like loading backwards in time. Like it started like with a full ring, and then it just started like filling in like the block data as it goes through. That's like what Brandon was trying to explain to y'all earlier, that like there's not really like in Bitcoin Core, there's not really like a get past 12 hours of blocks command. So it's like they basically have to, in the code, basically like, okay, keep getting blocks until we find one that like hits the timestamp that satisfies 12 noon or 12 midnight.
Yeah.
Right. We essentially have a pointer starting at whatever get blockchain info says is the most current block, and then we get each block back from that. Like it's literally individual RPC calls that we're having to make to get the previous timestamps, because we can't just say like, which is actually really surprising to us when we were looking into this, but we were like, we can't just get, hey, give me all of the blocks and their timestamps from the tip to however far in the past. We can't. There's no way to do that. So that was fun.
Yeah, and like I think maybe if you had Electrum or something like that, you could do it. But we started with the principle that like we don't want users to have anything else installed. They can just use a Bitcoin Core nodes, raw dogging Bitcoin Core nodes, and it will work.
Yeah, totally. So let me. I'm sure maybe you guys have questions or things you want to say. So let me just real quick show you a bit about the development environment. So we have a storybook that you can run for this, where you can see all of the states that we implemented. Doesn't mean other states couldn't be implemented in the future, but so we currently have connecting state, which I believe if I honestly can't. Koala, can you remember what the connecting state signifies? Like, I'm trying to remember what
Yeah.
call that translates to.
Yeah. So literally, when the component starts, it just tries to get blockchain info, and that's like the first RPC call that it's making to the Bitcoin Core node. And so we treat that as a connecting state because it's never done a successful RPC call before. It's almost as if it's just establishing a connection. So yeah, that's it. Once it's able to get a response for that get blockchain info call, it progresses to different states, and it presumes that the node is now connected. I put air quotes because like it's not like it's a gRPC connection or something like that. But yeah, that's what it means.
Right. Okay, awesome. Yeah, so it's essentially a loading state, an initial loading state. Once it does that, it may move on to syncing headers depending on the node, the state of the Bitcoin node, right? If the node is still syncing, this is what it would show, or I should say syncing headers. So this is kind of like a rarely seen, like the node is new, and then it will move on to IBD, or the downloading state, and so this will fill as the download progresses. Yeah, I think that's all there is to say there. From which it will move on once it's done. Once it's filled to 100%, it'll move to the actual block time, which we saw earlier. This is kind of like your standard state, right? The two other states we have stopped. This is actually like a manually passed down attribute on the HTML element. So like, you would have your block clock element or whatever, and this is just an example node that we have up. So I could pass like is stopped or whatever, and it would show this state. The reason for that is if you don't have an error state, like let's say you stop your node. So on the voltage dashboard, for example, you can stop your node. That's not really an error state, right? You're just turning off the node. So we wanted a way for our UI to know, like, hey, if you're getting a 404, right? If you can't reach the node, it's not because there's an error. It's because this was like intentionally stopped for whatever reason. That reason can be up to the implementation. So, and then final.
I was gonna say it might be worth mentioning there real quick, just that like this might be a good place to highlight some of the differences between like our nodes and like the Bitcoin Core app project. So like, I think it's like y'all are trying to build something that would run on like an Android tablet or something like that. So it's like every time the user would open the app, then presumably the node would kind of be online and come back to life. Whereas ours is more of like an enterprise cloud product. And so like it can be like any other cloud computer or containerized application. It can be like turned on and turned off at the user's will. So there is like, for us, we have this stop state that doesn't really exist for your use case. Anyways, that's all. Just want to highlight that.
No, that's a good point. And this might be a good point to talk about like the rest of them, right? Because you guys had, for example, a pause state that could mean various things. No Wi-Fi, not plugged in, tap to resume. None of these really applied to our use case because, like Steven said, we're in the cloud. So if they don't have Wi-Fi, they can't see our node anyway, right? Or they can't use the portal anyway. Not plugged in wasn't really relevant.
But they're quite easy to add. Like,
oh yes,
because,
yeah.
So just as like you guys didn't design the stop states, we added the stop states as a prop that you can pass the component, and then later you'll see that because everything's like kind of a components tree, you can just easily build whatever state you need, and then map it to a prop, and then put it on the storybook, whatever. So, for example, for no Wi-Fi on a mobile phone, it'd be something like the Android system will give you a flag saying Wi-Fi is off. You pass that into the components, and then in the components in the state tree, you just basically say, okay, if this prop for no Wi-Fi is on, show this UI. So it's quite easy to add it.
Right. Yeah, 100%. We yeah, go ahead.
Yeah, I think it's hard to predict anyway what exact states you really need, because especially with this no Wi-Fi thing, I mean, it could also be in a setting somewhere when we're talking about phones. You could also say, okay, allow over mobile data, right? So then I could have no Wi-Fi on the phone, but actually it would still load because I enabled mobile data. So I think it's actually very nice that you guys made it kind of configurable. I mean, this is I like it.
Yeah, thank you. We and to Koala's point, there we implement it in this state machine, and I won't get too into the weeds yet unless you guys have questions. But at a high level, there's a lot of state in this application, right? There's a lot of different faces, I guess, to the app based on what data is being passed in or the state of the blockchain or what have you. So we tried to implement it in such a way, like Koala was mentioning, that you could just kind of add one of these states here, and it's kind of laid out very nicely and logically, such that you should be able to kind of read the code here and understand what's going on, add your own state as necessary. So well, that's the hope anyway. But
Right. Yeah. So the what Brandon was just saying, that file there, that's like a state machine, and like software engineering terms, that's just basically a way to explicitly define all the states that your component is in and how they should behave when they transition between states. And it's all encapsulated in this one like TypeScript file. We're using this library called xstates. The point here is that you can actually take this file and put it in a completely different project and implement your own different UI. But the business logic of how the component connects, fetches the blockchain info, aggregates the blocks would still be there. Like it's all contained in this one file. And then you also, so apart from that, you also have kind of the UI rendering, and that's like separate to this file, completely like kind of agnostic to the business logic. Yeah, it's just kind of a programming design decision we made. It helps us come back to the code and like look at something we want to add to it, but it also makes it very modular, so that if somebody doesn't like this UI for some reason, they can just literally take this file and then implement their own UI with a different library, or maybe it's not a web component, or I don't know, you could run this on a phone potentially, if you can run JavaScript like React Native. Yeah.
yeah, and that's a good point, because like Koala said, this abstracts the UI from the logic, right? So the logic is self-contained. You can take it anywhere, build whatever UI you want. It's not tightly coupled, which is really nice. Okay, so and then the last thing is, so there's a storybook server. This is all in the README, how to set this up. There is also like an actual dev server where you're connecting a real node, right? It's very stupid simple. It's literally just the block clock and then some debug information if you set that flag to true. And so just to kind of show, like I showed this file a little bit earlier, but like this is just a standard HTML file, and we literally just put the block clock web component in here, passed in some of the variables so that you can play around with it. One thing to note, this is in the README, but there is, if you're running it locally, you need to proxy the requests essentially. And I believe I'm forgetting the reason off the top of my, oh yeah, okay,
So-
Bitcoin Core doesn't support cores headers. So if you try to do this from your browser running locally directly to making calls to Bitcoin Core, it'll just fail. So yeah, we have instructions for how to do that. If you have NPM, if you have NPX, or if you have NPM, I believe you automatically have NPX, where you can just run this command and it'll work. So for the vast majority of front end use cases, should be pretty easy to do.
Yeah, so this is
yeah.
connecting RPC directly to the nodes. Like Brandon mentioned, you need to set up a proxy because of the cores issue, but you're still connecting to the RPC ports and using the RPC user and RPC password, which is just something that you configure on the Bitcoin Core nodes. But we also have a different way to connect to it, which was to suit the Voltage needs, which is on Voltage when you have your node running in the cloud. We have a URL that you can use to call for make RPC commands. But to authenticate that URL, it's just like a bearer token that's in the header of the request. And so that's all you need to make you don't need the RPC user or RPC password, you just need a valid bearer token and this proxy URL. So you can run this block clock that way. Like it's specifically for our use case. So when you see the blue block clock on our dashboard, it's actually using the user's bearer token from his authenticated session and this proxy URL. And so if anybody wants to implement the block clock as part of their kind of website or service or something where users can connect to it, that would be the method they use rather than directly to RPC. Locally, you can just use the RPC endpoints and the username and passwords.
So yeah.
Okay, I think I
it.
got it, but I would have to look at it in more detail.
Yeah, I was
Yeah,
just,
no,
I was,
not a developer.
sorry, go ahead, Michael.
No, it was just so. What I think I got the point of it, but I'll definitely check it out and maybe try to get it going on my end, even though I'm not a technical person.
There was one question that I had. My brain couldn't quite fully understand it. The original design was designed around the 12-hour sort of cycle. And then with the current implementation that you guys did, for technical reasons, as far as I understood, and for visual purposes, you implemented the Mutiny net every 10 minutes, if I remember correctly, so that there can be a nice visual there.
Every hour.
So
Every
right.
hour. Yeah.
And I probably,
Yeah, so I think the reason was, so there are two modes. It's not like it's one or the other. If it's on mainnet, then it's the normal 12-hour interval. But on MutinyNet, because the block times are 30 seconds, that would mean if you would have a 12-hour, like in mainnet, if you would have a 12-hour interval, that would mean you would have 1,440 or something like that of these segments, which you will not be able to see. So in that case, the interval for MutinyNet nodes is just 1 hour, so you get 120 if I counted correctly.
yes. Yeah, that's
Yeah.
exactly right. We didn't take away anything in terms of the design in that case. We just added a state to where it was like, do you want these intervals to be 12-hour or 1 hour? By default, it's 12 hours. So, for most people, it's going to look exactly like what you guys designed. And that's what this is doing here, because this is a mainnet node. It was just because we have these MutinyNet nodes and we want to display them, we kind of had to add a case for our use case that wasn't in the design, and 1 hour was a good trade-off. But that is a property that you would explicitly have to set. So you'd have to come here and say 1 hour intervals. This is a Boolean. So if you add this little attribute to the block clock, it'll display them in 1 hour intervals. And you would only do that if it's a MutinyNet node. But by default, you don't have to worry about that. It'll just display like the normal 12 hours, just like you guys designed.
Nice. I was also,
Another. Oh,
go
go
ahead.
ahead, Mo. Sorry.
No, I was curious how the team, because this is the first time we've seen a live implementation. The Bitcoin Core QML team haven't implemented yet. But how did the team, come to the decision together that this was the right visual to have on the for the node runners?
Master designer Steven.
Okay.
It was just a conversation.
Steven likes to torture us.
Oh, come on! You enjoyed it. You enjoyed the challenging work. I thought, yeah.
He
It's
knew what we
Stockholm
would do.
syndrome.
Oh,
I
Stockholm
suffer from
syndrome.
Stockholm. Yeah.
Yeah. I mean, I started the conversation internally at Voltage. I mean, it was just that, when we embarked on the node project, our founder Graham wanted, something kind of fun for the dashboard. So I started, looking at ideas of, ways we could just add, something kind of cool looking on the dashboard that would kind of, indicate the state of the blockchain or whatever. And then I just remembered Bitcoin Core app, and I just kind of felt like I was, reinventing the wheel. Like there's already good, there's already, designers working on, this kind of problem of, if you want to call it a problem, there's already designers working on kind of adding a cool visual, adding some delight, adding some fun to the act of, running a Bitcoin Core node. I was like, why reinvent the wheel? There's already been a lot of design that's been put into this. So, that's where I took the, the design. I think I reached out to some of you about this, and then I took the design and just worked it into our Figma file, and we discussed it internally, and, then eventually came to the decision it was the right move. And I'm surprised we're the first ones to implement. I could have sworn I've downloaded Bitcoin Core Qt, like I've downloaded the test builds. I could have sworn I had seen the block clock in some of the test builds.
It is in the test build. I have it on my Android at the moment. I was actually just testing it last week, but I was wanting to test the create wallet flow, and I wasn't able to get to the create wallet flow. But the block clock is up and implemented. I kind of knew, sorry, just like someone outside of the actual project itself, like this is, that you guys decided to trust the design and run with it is amazing.
I have a question. First of all, great job, amazing that you use that, and awesome that it's useful outside of core. But my question is, so with your changes, with how you implemented it, with the changes, maybe outside of Mutiny, do you see things that could be maybe also changed in the original block clock? So like maybe things that you improved and think that you would improve the original implementation?
I remember one idea we talked about was making the segments hoverable, so you could hover over with your mouse or click them and actually see that block's information. I remember that wasn't part of the design. Other things like IBD estimation time. There is actually like dead codes in the repo right now where we made an initial attempt at it, and then can't remember if it was just math incapabilities or something else, but we couldn't actually quite get it right or useful, so we left it out. And then things like connecting peers, like those dots there that you see on the screen right now, we also just got rid of that because couldn't figure out a way to make it make sense for us, because we don't really display the peer connection parts. Just because for our use case, it didn't make sense. We're just kind of trying to aim for MVP as quick as possible. Yeah, other than that, I think the hover over segments is quite important one. Steven, maybe, or Brandon, do you guys remember anything?
Yeah, I can add some more color. There's one other thing I remember, and I can add some extra color to what you just said. Like with the peer dots, I think we had you guys had those at one point, and yeah, I took them. I asked you guys to take them out because they weren't really fitting our use case of like. So for us running enterprise cloud nodes, it's like you're always connected to the peers. Like your peers aren't going to be like connecting and then reconnecting all the time. And so like they're basically it's just going to be always, filled up. It's just not the kind of thing that, our users are really going to be changing on a regular basis. And like, yeah, it's like once you have peers, it's just like once you've filled up that 5 dots, you're good. I was actually, it got me thinking too about like how applicable it would be for the mobile use case that you guys are pursuing, because I feel like every time the node comes back online, it's probably just going to reconnect to the same set of peers anyways. So I'm not saying it's wrong. I'm just kind of putting the question out there. I wonder if you're ever actually going to have a situation where those dots are like fluctuating in a way that's actually meaningful to the user, especially if the user isn't doing any kind of like manual peer management. Like in an enterprise context, maybe you have some reason why you care about peering with specific nodes, but I think for most users, they're probably just like auto connecting to a bunch of peers. So I guess I was wondering if the connection strength mattered a whole lot. I think another little thing that that Koala and Brandon did differently was the loading. I don't think it was. I think it was just something that just wasn't specified in the design, but was like how the mempool loads. So the idea is that like as you're counting forward in time, the progression of time starts at the top of the clock at 12 or 0, depending on how you look at it, and then it moves around the circle clockwise. And so the segment should always be growing. It's like you think the second hand on the clock is, or the minute hand even, they're all the clock hands are constantly moving very slowly. So like their little they have like a little gray tip at ring tip at the beginning, and the gray thing is constantly growing, because it doesn't really matter how long it takes for the next block to arrive. That tip needs to be constantly growing such that when the new block arrives, it like solidifies. So I think you just have the gray tip growing in this one, and then when the next block it's like slowly growing. When the next block comes in, it just changes from gray to red. So that could be something kind of fun, maybe for the mobile app as well. And I think, yeah, to second point about like tapping, like clicking on stuff, I think the hovering over the rings to get some info would certainly be fun. I like the idea a lot. I think we just deprioritized it for our release just because it was like I was kind of like, this is a delight thing. Like this isn't like for like meaningful block data. Like I feel like if I really want meaningful block data, I'm gonna go to mempool.space or blockstream.info or something and like really dig into the block data. And this is just something more like it's like I see this as like procedurally generated art based on my current time zone and the current state of the blockchain. That's kind of what it is to me. It's just procedural art. Um, but I think that, yeah, that could be like a fun future feature, being able to tap on the rings and get more info.
And maybe even a link to, you mentioned mempool, maybe even a link in that hover tooltip to the mempool block that you're hovering
Yeah.
over, right?
Or maybe Bitcoin Core app implements some kind of block data. For us, it would probably be like a mempool link, but maybe Bitcoin Core app, like actually renders the block data directly within the app, because that's kind of part of the joy of the Bitcoin Core app thing is that it's like creating this, it's like, well, why would you run your own node? It's like, well, maybe if we create this, delightful experience around running a node on your Android tablet, then more people would actually do it. So for Bitcoin Core app, it might actually, could potentially be another screen in your application that shows a summary of the block's data or whatever.
Also, I don't know how hard is it to use Mutiny with Core, but if it's possible or easy, maybe we
Super
could
easy.
incorporate that. We could incorporate that your math you developed for this 1 hour clock for Mutiny.
Yes. So MutinyNet is literally just a fork of Bitcoin Core, and a couple things changed. I think it actually has some new bells and whistles, like it has OPCat and some of the fun Covenant stuff now, but
Yeah.
but it doesn't deviate much. And the main deviation is the 30-second block time. So it's a very, very small code change, which means that, Stephen and I have actually been on calls where we've spun up MutinyNet nodes on like DigitalOcean, on the cloud before, and it's really easy because it's just it's the same software. So all you have to do is add in your bitcoin.conf file the like the special parameters that you need for any signet. You just add MutinyNet's specific parameters for that, and it's really easy.
I'll go
Yeah.
ahead and say that there was actually some complications. I'm actually not sure if you'd be able to use MutinyNet as an option with Bitcoin Core app because in theory it's possible, but Bitcoin Core app is actually a maintained fork of Bitcoin Core. Like if you look at it,
Yeah.
there's like upstream commits from Core as well as the commits that your developers are working on for the Qt interface, and then MutinyNet is actually a fork, a maintained fork of Bitcoin Core. So Harold, Rod, and your other devs might be a little opposed to the idea of like merging in commits from another like fork of Bitcoin Core, especially if you one day like want this to become like the de facto Bitcoin Core interface. It might be a little bit of a weird. It might be a little hard to sell them on the idea that like you are also going to merge in these commits from another fork of Bitcoin Core. It just adds a lot of complexity to it. I don't want to
Yeah.
speak for him, but I imagine it might be a
Good
complicated
point.
thing.
No, it makes sense because then why, if there are other 5 forks, why wouldn't we add them, right? Like we should.
Yeah.
There's this also same goes with like linking to mempool space. Like it should be kind of the core should be kind of neutral of other products, I think, right? And other kind of
Yeah.
software if possible.
Yeah, absolutely.
That's a good point.
Yeah, MutinyNet is really good, and I think for your use case, like the mainnet and testnet and the regular SIGNet probably work very good. Because for your use case, like with a mobile application, trying to make it fun and easy to run a full node on your phone, you're really only going to probably be dealing with people who actually want to deal with mainnet. We have to consider the MutinyNet use case because a lot of our customers are other engineers who need very quick ways to test things without messing with real Bitcoin. So like MutinyNet is becoming a very, very popular developer tool for our user base, but it's probably much different than your potential user base with Core App.
Yeah, and one thing to note if you did want to fork this is that code change is pretty small. The addition to render MutinyNet nodes. So if like you wanted the rest of these features but not the MutinyNet part, that wouldn't be a huge code change to implement.
Oh, and that might be a good point for me to kind of like just talk about community contribution and all that kind of stuff, kind of like our like philosophy to this sort of thing. So this is open source now. Like we welcome collaboration, input, GitHub issues, GitHub pull requests, all of that kind of stuff. The one caveat to that is that like anything that gets merged into this repo, we need to make sure is like still compatible with the product that we like import this component into, which is like our larger Bitcoin Core product. So any kind of pull request to this repo would be like it would still need to. We couldn't do anything that would break compatibility with our larger product. I don't think that would be a problem because like if as long as things are new features and additions and tweaks, are added in a way that like kind of fits with the state machine that Brandon and Koala have defined, and it's built in a logical way. Like if you add something in that like we don't use, I think it's fine as long as it doesn't interfere with any of the props and features we use. If it gets to the point though where like that is becoming a burden, then this is open source, so the community could just take it and fork the voltage block clock to make like another block clock, and that would be fine too. So yeah, we welcome contributions and all of that as long as we can maintain compatibility with our existing product. Otherwise, it's there for the community to fork.
I was just curious, how long has this been now since it's been implemented? So full implementation of the MVP. How long has it been now?
Well, we open sourced it like very recently.
Okay.
Like
Friday.
I think Friday. Yeah, we've been using it in our in production for longer than that, but it wasn't open source.
Yeah. And how are the node runners, how are the users in terms of giving feedback? Because I'm sure so I'm imagining I'm a node runner and I have my dashboard. Would I then get this notification telling me, there's this new update and the update includes a block clock, and then do I want to install the update or something along those lines? And then you'll start, the user feedback will sort of start to trickle in. How, yeah.
Well, for us, it wasn't really like the block clock was the product. The product was really just self-hosted Bitcoin Core nodes in general.
Yeah.
We launched that on July 30th. I just put the tweet there, and so that was the big thing. It was just the whole product that what was effectively you can now run a Bitcoin Core node on Voltage, and you don't have to call us and strike up an enterprise deal to do it. You can just go to the web application and buy it the same way that you would a standalone Lightning node. So we haven't gotten like a ton of feedback yet, because it's only been like 2 weeks here, and this kind of product is targeted at a much bigger enterprise customer. The Lightning nodes are more for like people who want to build Lightning web applications and stuff, whereas like the Bitcoin Core nodes are, not saying it has to be this way, but frequently it's for like much larger companies that are dealing on chain. I did do some, UX research kind of at the beginning of this, like getting people on calls, showing Figma files to people, all of this kind of stuff. A lot of times the reaction I got from, like the immediate reaction I would get from everyone I saw it was, I don't know what that means. But it didn't bother them also. They would say, I don't know what that means, but I don't care. Like, which I was actually fine with, because like, they're occasionally in early designs, I'd get, people would say, I don't know what that means. And they would kind of fixate on certain details of the product. And I'm like, okay, this clearly really, bothers them or leaves them with a lot of confusion. But the kind of like block clock response was like, I'm not sure exactly what that is, but it kind of looks cool. I'm not bothered by it. It has something to do with the blockchain, and that looks cool, but I'm not sure immediately. So yeah, that was like,
we did some user testing, not precisely to focus on block clock, but in one of the tests, block clock was visible at the end and had very similar reactions. Yeah, so I think Christoph had an idea how to kind of introduce it better. I don't remember exactly if it's like designed or not, but
I don't remember, but aren't there a few of the screens dedicated on the onboarding flow to introducing the block clock? At least 2 screens, but I don't.
Yeah, there is.
Yeah.
There is one screen, but yeah, I think Christoph has some idea to introduce it, like expand it, or like, yeah, I don't remember exactly. I don't want to put words in his mouth. I mean, it's not a big issue, but technically, it's not obvious from the beginning. Yeah. What is it from just looking at it?
And I'm fine with that as long as it doesn't distress anybody. Like I actually think it's kind of fun. Like, it's kind of like old video games. You used to dive into the game and just like have to figure out how the game works. And, you're running along and then a plant eats you, and it's like, oh my God, I got eaten by a plant. Maybe I should try not stepping on the plant next time. Like, used to be you figured out old video games, and now in like modern video games, it is like everywhere you go, they're like telling you press this button to do this, and press this button to do a combo, and blah 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 blah, and they like explain everything. I think there's actually a little bit like something fun that just like user interfaces that like don't have to explain everything to you. Like you log into like modern web applications and like, welcome to a tour of our application. Go here, click this, click that. It's like sometimes it's just fun to have a little bit of like silence and just like have
Mystery
something
as
that,
well, right?
yeah, it's
Yeah.
like I don't really actually like, I just see it as pure delight. It's just like it's to me it's just procedurally generated art, and it's like maybe the 10th time I log into my dashboard, I'm like, huh, the ring always seems to be like at the same time of day that it is. Like it's always like the ring is always over here because I'm always, logging in at 9 a.m. Why is that? And then like the next time I log in, it's like starting from like, oh wait, the ring isn't filled this time. Why is that? Oh, maybe because it's noon or it's midnight or whatever. Like you start to pick up on it over time. And I just think it's more of a fun a piece of fun more than it is like actionable information.
Yeah, I agree. And nothing that like the block clock gives you is kind of, I guess, crucial information from like, like the spread of block times, right? Is not something I think people, unless you're like a researcher, are typically needing. But it's still something that's, like you guys said, introduces a lot of kind of mystery and fun, and it's like a quick. It's cool to be able to see what's happening on the blockchain at a glance, if that's what if I guess like you don't necessarily really want that, but it's cool to have that in a way. So yeah, it's like they're not missing out by not having this information readily explained to them. This is probably not what they're going to Bitcoin Core for, but it's really cool to be able to just see that. And once you figure it out, it's like, oh, that's cool,
Is my mic working? Can you hear me?
Yeah, yeah.
Yeah.
Okay. Sorry, I'm having internet issues. Yeah, one thing we did mention, like brainstorms, was when it's like on this screen, like block time screen, that it could switch to, for example, fee estimation, kind of like, or like have it swipe. So yeah, one discussion was like, oh, the dots kind of look like when you have watch faces that you can swipe, like either automatically change or when the user clicks or when he swipes. Just remember we brainstormed stuff like that. Like, oh, we could show additional information on without cluttering the existing screen, but like on other screens that yeah.
Nice idea. I wish it existed when China banned Bitcoin and then the block times increased to like 20 minutes or even more, like half an hour.
Yeah.
Then the lines in the block will be much longer. So yeah, you can really nicely see at first glance that the chain is kind of alive and that it's kind of organic in a way that it's changing.
Yeah, you can do a lot of fun stuff. I can imagine like you can even show a chart of hash rates, or yeah, like fee estimation for like low, medium, high priority. Yeah.
You could highlight important blocks like Mempool does with the halving or whatever.
Yeah. Oh, you put a halving Easter egg. You should do that before.
That'd be fun.
Before the next halving.
Yeah, just like just build it in there, and then if other people import the block clock library, then when the next halving rolls around, it'll just be they won't even know it. They'll just get whatever they get 4 years from now.
Yeah.
Well, cool. So we're kind of approaching the hour here. So we probably need to drop soon. Is there any final burning question before we wrap things up?
Nothing from my end. I just want to say kudos to the team for having the patience to build this out.
Kudos to you guys for designing it.
Yeah.
Yeah, wanted to say the same thing. I think the approach that you guys took with making it kind of configurable so that you can make it work for your use case while still thinking about how to, about other people, how they could be using it. That's great. Great job.
Thanks, guys. We had a lot of fun building it. So
Great. Thanks everyone for joining. I'm not sure about Koala, but Brandon and I are both in the Bitcoin design Discord. So, reach out if you ever have any questions about using it or anything like that. And yeah, it's been a super cool project to work on. So I'm glad that we were able to, get involved with an open source project like this. So thanks for joining, everybody.
All
Okay,
right.
Steven,
Good
thanks.
morning.
thanks, everybody.
Later.
Good to meet you guys.
Bye bye.
Same here.
Bye.
Bye-bye.